Okay, so today, guys, I'm going to introduce you to these things called the trigonometric ratios. Who wants an extra point? Who can tell me what a ratio is? What's a ratio? Yeah, John? Say that again? The signs of a circle? Is that what you said? Signs of a circle? Not what I'm looking for quite. Not what I'm looking for quite. So I'll give you a point for your shot at it. But anybody else want to define ratio for me? You can give an example too if you want. There you go. 2 over 1, right? So say, go ahead. Now what? 2 out of 1, right? So over 1 or out of 1. Good. All right. Those are both ratios. So what is a ratio then? A ratio is where you are comparing two values, right? Like the number of boys to girls in the class, right? That would be a ratio. So there's these things called trigonometric ratios, and we're going to learn what those are today. So let's start off with a quick little observation here. I don't think you guys need to write this down. You guys can just watch for now. Okay, so these two triangles they have the same angles, but you guys can see that one over there is smaller, right? All right, more bonus point time geometry question. What do you call two triangles that are pretty much the same, just that one's smaller than the other one? Nice job. It's called similar triangles. Good. Similar triangles have all the same angles, but one's a different size than the other one. All right, so here's what I want to do is I want to go through and I want to find all the missing sides here on these triangles using what we know. So do you want to go? What? Do you want to tell me the sides? Yeah, tell me the hypotenuse first. For this triangle. Oh, that's okay. That's okay. I'm gonna open it up to people here. What do you think, Malak? Why is it 6, Malak? Because you multiply the short leg by 2, right? And let me get some more bonus points out here. So how about this side over here? Someone want to chime in on that one, Perez? Multiply what by radical 3? That's right. So this is going to be 3 radical 3. Okay. Now let's do the other side over there. So George, what's the hypotenuse here? Good. And Braden, what's the long leg here? Good. Okay. Now here's what I want to show you. I want to show you guys something interesting. Amber, pick 2 sides for me on the triangle. We have 3 to choose from. Hypotenuse, short, and long. So pick any 2 sides, please. So you want to do hypotenuse and short. All right, I'm going to make a ratio out of the hypotenuse and the short leg for each triangle. Okay? So if I did that, what is 6 over 3? It's 2. I'm going to still write it as a ratio, 2 over 1. But there you go. So the ratio of the hypotenuse to the short leg is 2 over 1. Let's do it with this one over here. What's the hypotenuse on this one? And the short leg? If I reduce it, what do I get? You get the same answer. So here's what I want you guys to understand from this. The size of the triangles doesn't matter. If they are similar triangles, then they will always have the same ratio if you're using the same size. Let's pick another one. Let's say that we wanted to do long over short. Long over short. Let's do that. So if I did long over short, what would this one be? It would be 2 radical 3 over 2, which is radical 3. What if I did this one? 3 radical 3 over 3? It's radical 3. So it doesn't matter how big the triangle is. If you're using the same size for each triangle, you get the same ratio. Okay? That's what we call a trigonometric ratio. So what is a trigonometric ratio then? A trigonometric ratio is the ratio of any two sides of a triangle. And it doesn't matter how big the triangles are, it will always be the same. This one here has a name. Hypotenuse over short. It could be, actually, it could be called two different things. One thing it could be called is cosecant. Another thing it could be called, we abbreviate it CSC, but it's cosecant. Another thing that it could be called is secant. And it kind of depends on something that we'll get to later. But that ratio has two different names. Okay. So what they've done then is they've come up with a name for all the ratios that you could possibly make out of a triangle. Okay, now here's another bonus point. Okay, how many different fractions could you guys possibly make? How many different fractions are possible? Pick two sides, make a fraction out of them. How many different fractions are possible there?
6.
6. Nice job. Good job. There are 6. There are 6 trigonometric ratios. Why are there 6? Well, I don't know how you got that so fast, but there's probably a few ways to do it. But you know, you could do 4 over this or 4 over that, right? Then you could do 2 over this or 2 over that, or you could do 2 over that or 2 over that. So each one goes with 2 others. There's 3, so 3 times 2 is 6, right? There's 6 possible trigonometric ratios, and there are 6 names. Their names are sine, cosine, tangent, cotangent, cosecant, and secant. This one is, like I showed you before, either cosecant or secant. All right, so that's what a trigonometric ratio is, and trigonometric ratios are kind of like, it's kind of what everything is, it's what trig is based on. So trigonometry is completely based on these 6 things. So let's go ahead and write down what a trigonometric ratio is. Okay, so, but we need a way, if we're going to talk about this, now, let me back up a little bit. We were just doing a 30, 60, 90 right triangle. Now, these trigonometric ratios apply to any right triangle, okay? So it's not always a 30, 60, 90 right triangle. And using the vocabulary, short, long, and hypotenuse is going to be a problem. You guys can maybe see how that would be an issue if we're talking about 45, 45, 90, right? Because there is no short and long on there, right? So instead of using that vocabulary, we're going to change our language a little bit, and we're going to use these 3 words instead to describe the sides of the right triangle. The 3 words are opposite, adjacent, and hypotenuse, and that works for any right triangle. So I'll show you what we mean by that. So let's talk about the sides of a right triangle real quick here. Naming the sides of a right triangle. Okay, so here's how we're gonna go about this. We're gonna start by picking one of the acute angles in the triangle. Not that the only one you don't use is the 9-degree one, but we'll pick one of the acute angles, like this one here. I'm gonna call it A, and that's the reference angle. I guess I could call it B. If you guys don't want to change it, you don't have to. Or not B. I could call it R for reference angle, right? Just for the heck of it. But if you don't want to change it, you don't have to. So I'll call it R, though. So that angle there is what we call the reference angle. Now, why is it that I call it a reference angle? Well, I'll explain that in a minute. That's right. So Conacher kind of answered it. And so what it is how you name the sides depends on what angle you're calling the reference angle. Okay? Here's what I mean by that. We have 3 sides on this triangle. We have one over here on the left, we have one on the bottom, and then we have this one. Now, here's the cool thing with a right triangle, the hypotenuse is always the hypotenuse. Okay, that's not going to change. So this is what we already know. This is the hypotenuse. Right? We already know that. So go ahead and write that down. That's true for every right triangle. You can always identify your hypotenuse. It's always the one directly across from the 9-degree angle. That will be true for any right triangle. However, how we name the other 2 sides is going to be based on what reference angle you're working with. So here's what the other 2 sides are called. They're called opposite and adjacent. Now if I say opposite, well, you can only tell me what the opposite of something is if you know what that something is to begin with, right? So if I were to tell you right now, who am I opposite from? What's your answer? Amber, right? So it depends on where I'm at. I'm the reference point, okay? So if I'm here, Amber's opposite from me. If I'm here, now Nick is opposite from me. So what you're calling your reference point depends on what you're going to call opposite. So here's how this is. This is my reference point down here. This is my reference angle. So which side is opposite from that angle? Is it the one on the left or the one on the bottom? What do you guys think? It's the one on the left. It's all the way across from it, right? So this is what we call the opposite side then. The other one has a word that we don't probably use a whole lot in our daily language, but it's called the adjacent side. Adjacent means next to, okay? So Nick is adjacent to Xanath. They sit right next to each other. That's what adjacent means. This side is next to your reference angle. It's sitting right next to it, right? It actually touches it. It's actually one of the sides of that angle. Now somebody might say, well, wait a minute, isn't the hypotenuse also adjacent? Yeah, but he already has a name. That's the hypotenuse. So the adjacent side is the one that's next to the reference angle that's not the hypotenuse. Okay? So that's how we're going to name the 3 sides, opposite, adjacent, and hypotenuse. So now I'm going to draw the same triangle again, but this time I'm going to change my reference angle. Instead of putting it down here, I'm going to put it up here. So now that's my reference angle. So if I do that, what am I going to call this side? That's still the hypotenuse. That does not change. But now which side is the opposite side? The bottom side is the opposite side. And now this one is the adjacent. So you guys, that's what we mean by reference angle. It's called a reference angle because it's your reference point. It's where you're starting from to name the sides. Okay? Can I move on? All right. So let's practice this a little bit. Just want to make sure you guys are kind of grasping this content. Okay. You don't need to draw this. Just hang out with me here for a second. So let's say that this is my reference angle here. I'm going to label these sides, and I'm just going to call in some people at random here. So here we go. So I'm going to ask Amanda Deep, which side is my hypotenuse? Good. And Gabriel, which one is my adjacent side? B is opposite. C would be adjacent. Let me throw another one up here. Think about what you guys think are opposite, adjacent, hypotenuse. What do you think, Edward? Which one is the adjacent side here? B. Good. Good. Kalani, what's the opposite side here? C. Let's see. Gabrielle, on this one, if I told you this is my reference angle, what's the opposite? Because I want to know. Okay, good. All right. Melanie, which one's the hypotenuse? Okay, good. All right, very good. All right, so you guys feel like you got this okay? All right. So that's that. So now that we know how to name the sides, let's move on to, am I on part B? I don't remember. See? All right. So what are the 6 trig ratios then? So I told you what a trig ratio is. Now I'm going to tell you all 6 of them. I want to draw this little triangle here. We got to pick a reference angle, so I'm going to call this R here. Oh, that's not right. Got carried away there. A. So we'll call this one B and this one C. Just to kind of stay faithful to our Pythagorean theorem there. So what are the 6 trigonometric ratios? I still didn't. I'm sorry, Hunter. Oh, yeah. I named them all, right? But now they need to know what are the fractions that go with those, right? So there's, first of all, let's go ahead and start with, I'm going to start with the name, okay? The name. So the first one I want to share with you guys is sine. That's what its name is. It's called sine. Okay? What is sine? Sine is opposite over hypotenuse. Sine is opposite over hypotenuse. Okay? Now, how do we write this then? Here's how you write it, okay? So sine, and next to sine you have to put your reference angle. What's my reference angle? R. I'm calling it R. If you don't have that, then you don't know sine. Because if you don't know your reference angle, then you don't know which is opposite. And if you don't know what opposite is, you don't know what sine is. Because sine is opposite over hypotenuse. So sine is opposite over hypotenuse. What is opposite from R? On that triangle on the right there? A. And what's my hypotenuse? There you go. So sine of R is A over C. Okay? Let's do another one, number 2. The next one is what we'll call cosine. It's similar to it. The ratio for cosine is adjacent over hypotenuse. I'm hearing some people saying this stuff. That's good. You guys remember your geometry. Cosine is the adjacent side over the hypotenuse. So here's how you write it. We write COS for the abbreviation. Once again, you need to include your reference angle. And it's adjacent over hypotenuse. What's the adjacent? Good. B over hypotenuse C. B over C. All right, let's do the third one. third one is tangent. Tangent is, good job, opposite over adjacent. Opposite over adjacent. So here's how you write it. Tangent of R is what over what? Opposite over adjacent. A over B. Good. Okay. Now, the next one is going to be cosecant. Oh, I'm writing the abbreviation. Cosecant. In parentheses here, I'm going to, yeah, I'll write it. It's the reciprocal of sine. So, sine was opposite over hypotenuse. So what's cosecant? Yep. And here's how you write cosecant. You put CSC, that's cosecant, then your reference angle, and hypotenuse over opposite would be the same thing as sine, just flipped over. Instead of A over C, it's C over A. Next we have secant. Secant is the reciprocal of, what do you guys think? Cosine. It's the reciprocal of cosine. So it's going to be what over what? Hypotenuse over adjacent. And here's how you write cosecant. I'm sorry, secant. It's SEC, R, and cosine was B over C, so secant is C over B. And we said there were 6, right? So there's one more. That's my next slide. You don't want me to give you the next slide? So you don't want me to tell you how to memorize it? Why'd you ask the question? You just wanted to hear what you wanted to hear, huh? All right, here we go. The next one is cotangent, which is the reciprocal of tangent. I don't know if I'm spelling reciprocal right, but hey, we live in a world of spell check. So tangent was opposite over adjacent, so cotangent is adjacent over opposite, and we write it like this. B over A, right? Because tangent was A over B, so cotangent would be the same thing but flipped. Say that again. So I wrote tangent's up here, right? And that's opposite over adjacent. But this is cotangent, which is adjacent over opposite. Oh, thank you. How I wrote it. I got you. Yeah, you're right. That is an error. The abbreviation for cotangent is COT, you guys. I made a boo-boo there. Thank you, Mel. All right. I'm going to pause here. Well, actually, you guys could probably just use your cell phones. So go ahead and get out your cell phones real quick. I want to go back to something that we had earlier today. Okay, so we did let's do sine of 60. Now, if I'm making 60 my reference angle, sine is what over what, according to your little list right there? Opposite over hypotenuse, which is 3 radical 3 over 6, right? Now that one's confusing. Let's do cosine. It works, it's just not as obvious, so I wanna work with something a little bit more obvious. Let's do cosine. Cosine of 60 would be what over what? 3 over 6, right? Now, I want you guys in your calculator, I want you guys to push cosine of 60. Do cosine of 60. You can use my calculator if you want to, but just push, if you're using a cell phone, you'll have to push 60 first and then cosine. If you're using a calculator, usually push cosine first. Okay, good. Are you guys getting 0.5?
Yeah.
So your calculator knows. Your calculator knows that if you type this into it, it's been programmed to realize, okay, I'm talking about a triangle that has a 60-degree angle here, and opposite from that, whatever that is, the hypotenuse would have to be twice as much, so the ratio would have to be 1 over 2. And so it knows it's 0.5. Okay? So for us, we've memorized 45, 45, 90, so we could get all their ratios. We've memorized the sides for 30, 60, 90 right triangles, so we can get all their ratios. But something that we can't do is we can't do this. If I told you that was 70, and I asked you what is cosine of 70. Well, we don't know this, and we don't know that. Even if I put a number here, you guys don't know how much bigger the hypotenuse is than the short leg on a 70, 20, 90 right triangle. We never memorized that. So we're stuck. We can't figure that out. But our calculator knows. Our calculator knows what the ratio of this side to this side would have to be. So if you type in cosine of 70, what does it tell you? 0.34. So what that means is that this side here is 0.34 times the size of this one. So if you divide this by 0.34, you can find out what this is now. So our calculator knows what the ratios are. Okay, we don't. We only know the special right triangles. And that's why on your 45, 45, 90 right triangle, or the unit circle I mean, we only deal with the special angles. We don't have all of them. Okay. Okay. So that being said, Zanab asked, how are we going to remember all that? Does anyone remember how to remember it? Yeah, it's called SOHCAHTOA. How can we remember this? SOHCAHTOA. So here's how it works. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Okay? So that's your little memory trick. What about the other three, though? You just have to remember something else. What do we call the reciprocal of sine? So cosecant is the reciprocal of sine, right? You also need to remember that secant is the reciprocal of cosine, and you need to remember that cotangent is the reciprocal of tangent. So, for instance, if tangent is opposite over adjacent, then that means cotangent is adjacent over opposite. So, memorize this, which is easy. You could do that right now. SOHCAHTOA, right? Then you got to take a little extra time to memorize which ones are the reciprocals of which ones. And here's how I remember which ones are the reciprocals of which ones. the S goes with the C and the C goes with the S. It would have been nice if they had the S's match and the C's match, but they didn't do that. It's the opposite. But that's okay, because it's the reciprocal anyway, right? So, since they're reciprocals, the C goes with the S, and the S goes with the C. I don't know. That's one way you can remember it. And cotangent's obvious, because it has almost literally the same name. So, there you go. So, let's go ahead and do a practice problem here. Example 1. Find the given trig ratio. So I'm going to draw a triangle and give you a trig ratio to find. Here we go. That's theta. That's our symbol for angles, right? I guess we'll start off with one of the easier ones first. So there, you're going to see problems like that on your homework. These will be the first ones you guys see. They're going to give you a triangle and a trig ratio, and your job is to figure out what it is. Okay? So first of all, let's remember, without looking at your notes, try to do it without looking at your notes. SOHCAHTOA. Opposite over adjacent, right? So it's opposite over adjacent, right? So if this is my reference angle, what's my opposite? Over. And you do need to reduce. There's your answer. That's simple. Okay? Let's do another one. Number 2. And let's see, what do I want to do here? Let's do secant. Okay, so I'm going to walk you guys through the thought process here. Sam, is this one of the 3 normal trig ratios or one of the reciprocal ones? One of the reciprocal ones. What now? That's not really a fair question, so let me explain what I mean by that. What I mean by normal is it's one of the SOHCAHTOAs. SOHCAHTOA is sine, cosine, and tangent. Another way you can know which one of the normal ones is the ones that are on your calculator. Look at your calculator. They only gave you sine, cosine, and tangent. They don't have buttons for the other ones, right? So we're going to call sine, cosine, and tangent the normal ones. We're going to call the other ones the reciprocals, okay? So secant is one of the reciprocals. Okay, so now my next question is, Haley, it's the reciprocal of which one? Sine, cosine, or tangent? Secant is the reciprocal of which normal one? Cosine, good. So now we're going to move on to asking Xana cosine. Don't look at your notes. SOHCAHTOA. What's cosine? So what over what?
Opposite over adjacent.
That would be COA, but we just want co. You sure?
Wait, so yeah, I'm confused. Okay. You said which one? Cosine? It's opposite over adjacent.
What do you think, Perez? Adjacent over. Oh, it's ca. It's not co. It's ca. So it's adjacent over hypotenuse. You confused me too. Shame on you. Ka. So ka, toa. So it's ka, right? Adjacent or hypotenuse. But as we said, this is the reciprocal of that. So if that's the reciprocal, Quinn, what is secant? Hypotenuse over adjacent. Now, the easy solution to this, you guys, is just to look at your notes, right? But you can't look at your notes on the test unless you want to be capped, right? So I'm trying to teach you guys the process I go through. Normal or reciprocal, okay? Then SOHCAHTOA, then figure it out, okay? So secant is hypotenuse over adjacent. So I'm going to ask another person here, what is my hypotenuse over adjacent then? So Nicole, what's the hypotenuse? Over adjacent. 21. And once again, we do need to reduce. 7 and 21 do reduce to. You could write 1 on the top if you want to. I'm just going to leave it as that, though. Okay. One more before I let you guys practice these. I want to show you one that the crappier ones that you have to work with, because there are some that kind of do something unpleasant. Let's do sine. Oh yes, thank you for asking. Yes. So Steve, what do you think? Is this one of our 3 normal ones or one of the reciprocal ones? So we don't have to worry about flipping anything. We can just go with SOHCAHTOA. So John, is this so, ka, or toa? Good. So if that's the so, Andrew, sine is what over what? So. So look. Okay, so opposites definitely involved, but it's so. There's 3 letters. Sine, opposite, hypotenuse. Good. Okay, so if it's opposite over hypotenuse, Malak, what's my answer going to be here? Okay, so let me tell you what's wrong with this one. First of all, we do need to reduce. 5 goes into 10 how many times? Twice. You can't have square roots in the bottom. You remember that? So we got to fix that still. That's a 5. So now we multiply the top and the bottom by? And so your final answer will be 2 radical 5 over 5. So you do have to rationalize, you do have to reduce. So I would encourage you guys to go through, as you're doing these exercises, try to do it without looking at your notes to remember what the ratios are and go through that SOHCAHTOA process. Okay? But you can do as you please. I'm going to throw a couple at you here. Okay, so there's 3 for you guys to work on. So for number 1, opposite over hypotenuse would be 16 over 12, which reduces to 4 over 3. Okay? For number 2, I don't know why I keep flipping it over. Cosecant. Yeah. Huh? I did. Yeah. For number 2, secant is hypotenuse over opposite. So it's radical 5. And then the last one here, secant is hypotenuse over adjacent, which reduces like this first. And then if you multiply the top and the bottom by the square root of 3, you end up with this as your final answer. Okay? So, go ahead and get out a piece of paper. You need a pencil. We're going to do our unit circle test on the coordinates. Put everything off your desk except for a piece of paper and a pencil. These answer with the denominators always do. So yeah, I think it's really wrong. My handwriting was a